Hi students, a very warm welcome to the Global Stat Academy, the statistics for data science. So today we are going to talk about shade. To start with shade, I would like to mention that shade and cart are the two oldest type of decision trees, and they are also the most common types of decision trees which are used in the industry today, as they are super easy to understand while being quite different from each other. So we'll talk about what is shade actually. So it is a chi-square automation interaction detection, which is a type of a decision tree technique and is based on the adjusted significance testing. We can call it as a Bonferroni testing also. And this type of test technique was kind of developed in a long way back, which is published in 1980 by a famous scientist. So generally, to start with the shade analysis, I just want to give you a brief background. What is a decision tree, right? So it is kind of a flowchart like structure in which internal node represents a test on an attribute. Say for example, whether a coin flips, comes up heads or tails. So each branch will represent the outcome of the test, and each leaf node represent a class level. That is when the decision has been taken after computing all the attributes. So basically, shade is an algorithm used for discovering relationship or establishing relationship between a categorical response variable and other categorical predictor variables, right? So it is one of the most widely used and practical methods for supervised learning, and decision trees are kind of a non-parametric supervised learning methods which can be used for both classification and regression tasks. Slowly and steadily that what is shade is. So shade, as I mentioned, it's a chi-square automatic interaction detection and is used to build a predictive model based on a classification system. Right? The analysis is kind of subdivides the sample into a series of subgroups that share similar kind of characteristics for a specific response variable, and it can maximize the ability to predict the values of the response variable. Where we can use shade. Shade is very often used to understand the characteristics of the most least satisfied customers or employees, right? And it also helps the client to target its potential clients for more efficiently and successfully. Basically, it is used in the direct marketing industry to identify the types of the people who have reacted to a specific campaign. How we can use it? So the first predictor category is the predictor that is associated with the most with the response variable. Each group is then kind of split it until the analysis does not find any significantly discriminating predictor anymore. The output is a tree of which the branches are predictor variables that split the sample in the discriminating groups. I have tried to make it a more lucid way, because if you are trying to if somebody is giving an interview and people are asking you, you can take these examples to explain on the layman's terms what I just explained. Now the last part is tools for the deployment. So knowledge seeker, you can deploy it, and it almost look like a branch. That is, here say for example, what is the overall satisfaction? So it will create different branches, like satisfied with the availability of the product and not satisfied with the availability of the product. It is 1 and 0. Then it will again create a branch with the other respected variables, that is whether he received monthly billing, or what is the not satisfied with the quality of the products. And this is the end nodes which will take what are the node values and what is the percentage, and based on the mean. So it will create the branches. So at the end, if you see what is the customer mostly satisfied, that is their overall satisfaction is 8.8, and and it represents 10% of the total sample. And if you see customer least satisfied, the average overall satisfaction is just only 2.8 if we compare to 8.8 mean value, and they represent only 9% compared to the 10%, right? So this is all about it. Thank you, and watch out for the next video. Thanks for joining.